Hello, Science 20. We are back and we're going to be starting our next topic in Unit C. Uh, this topic, we're going to talk a lot about geology and in a lot of cases, we're going to go a bit deeper into what we've been doing before. So we're going to start off with revisiting something we've talked about already, but we're going to go in a little bit more detail. We're going to talk about the process of uh, preserving any sort of evidence of ancient life in rock. This is, of course, what we call making fossils or fossilization. And so you can see we kind of have a basic pattern that we're going to follow. We start off with a living creature because you can't have a fossil without a living creature. That creature then needs to die, but before it can fully break down, it needs to get buried. And this is going to cause a preservation of this remnant, which will then be discovered and carefully recovered by us. So, when it comes to things uh, like this trilobite here that has shells, those are really easy to find unaltered. Teeth and other similar hard parts like bones are also going to be very commonly found as fossils. And when we say that the original material has been replaced with minerals such as silica, this is where we say that the uh, fossil is petrified, petrified meaning turned to stone. Now, under some conditions, the shells and teeth can dissolve, and this leaves behind a mold of the fossil. So these mold fossils are quite interesting in that they can actually give us a little bit more detail on some of the organisms that those other fossils wouldn't give us. So, for example, um, if the outside of shell uh, has this mold made of it, the outside is the external fossil, the inside is the internal fossil, and we can see things like muscles that were attached to the shell. Now, soft tissues such as skin, muscles, leaves, and other tissues can be fossilized as well. What we see is a complete replacement of the organic material, and it gets preserved under a very thin film of carbon. Now, as we talked about before, most fossils are going to be found in sedimentary rock because their remains are going to be buried with sediment over time. And this usually is going to happen at the bottom of oceans, but things like mudslides could also create the perfect conditions for creating these fossils. Some fossils have been found in igneous rock, so lava will quickly flow over the organism. Sorry about that. It'll flow over the organism. And these are usually going to be large things that have a hard time moving. So, like a tree would be a good example of this. And the lava then will create an impression or a mold, which can then be filled with minerals. And this can create a cast, so to speak. So, here we can see an example of one of these. And I'm just going to get rid of uh, the red lines here. Don't really need those in here, but here we can see that in the outside of things uh, would be along in here. That's going to give us some information on what the outside of the organism looks like. Well, we'll see some stuff happening on the inside as well. So, anyways, just a quick little example of that. Now, minerals that are going to be involved in fossilization will be calcite and silica. Calcite, main one like this is going to be calcium carbonate, whereas silica is going to have silicon compounds. Now, when we compare fossils, they can give us a good deal of life uh, on what life was back in ancient times, but also gives us link to some of our modern day organisms. So there's a group of worms called Canadia. And these Canadia worms, here's a fossil of one of them. Now, they bear a striking resemblance to worms that we have today. Uh, and this worm, I forget the bristle worm. There we go. So these bristle worms and the Canadia worms look very similar to each other. So that probably indicates that this guy's an ancient descendant of what this guy was hundreds of millions of years ago. Now, when we are looking at fossils from different eras, we note a lot of common features and patterns. And usually, what we see is we tend to see organisms start out being very simple, and they become more and more complex as they get as we move through the eras. This is going to provide us some evidence of evolutionary change. And so what they say is, these uh, features and patterns are coming along because they may have provided individuals with those traits an advantage in their given environment, and they can become more specialized as the environment becomes a little bit more specialized. So that's everything for this first lesson. So go through it, give a good read over, and if you got any questions, as always, feel free to email me or ask me in class, and I'll see you in the next video.